Okay, we're on question number 40 of the Volume Test Review 2 worksheet. This question is essentially the exact same kind of question as question number 39, so you should be pausing the video and trying this on your own. Remember, you're going to find the volume of the larger cylinder and then find the volume of the inside cylinder, and that one's being cut out, so you're subtracting that. Once you've attempted this problem, I will go over with you just the basic numbers. You should find that the volume of the large one, or the outside cylinder, should be 16,458.8 inches cubed. And then the smaller one, and you got your dimensions inside here. You know the height is 31 inches, and then you've got your smaller radius here, which is going to be 5 inches, and you've got your larger radius down here, and that one is 13 inches. So anyway, the smaller volume, let me get that inches written at least readable there. The smaller volume is going to be 2,434.7 inches cubed. And now you're going to subtract the larger one, or sorry, the smaller one from the larger one, and you're going to end up with a volume of, look at this, yeah, 14,024.1 inches cubed, and that should be 16,458.8 minus 2,434.7. Alright, let's go to number 41. The object below is a rectangular prism attached to a cylinder. Looks like a camera, but you can see I've got a rectangular prism in the back and a cylinder in the front. What is the volume of the object? Now this is different from the previous one, because now instead of subtracting one volume from another because we're cutting it out, in this case we're finding two volumes and we're adding them together. So you're going to have to first find the volume of the rectangle. Well, you could do the cylinder first, but I'm going to go ahead and do the rectangle first. Well, I know my base area of a rectangle is length times width. I'm going to go ahead and just pick the bottom of this rectangle as my base. That means this has to be my height. And this 6 foot up top is also the same dimension down here if it's a rectangular prism. So I've got 12 times 6, which is 72, and that's going to be feet squared. My height for my rectangular prism, I circled that, is 14 feet, and my volume is base area times height, which is 72 times 14, and I'm going to end up with 1,008 feet cubed. So there's my first one. Let's put a box around that just so we keep track of our main numbers for later, since we're going to use this again in a few moments. Alright, let's go ahead and find the volume of the cylinder. Now this one gets a little bit trickier to find the dimensions. If you take a look at this 4 feet, that's our radius. And then this 4 feet, this is our height. So if this is our base, this circle right here, we've got a radius of 4 and a height of 4. So our base area of a cylinder is pi r squared. Our radius is 4, so 4 squared. And so we've got 16 pi feet squared. Our height is equal to 4 feet. Our volume is equal to base area times height, which is 16 pi times 4. Let's put that in our calculator, and you're going to get approximately 201.1 feet cubed. Let's put a box around that one. And now we're going to be adding these two together. So to find the area or the volume of this composite shape, you're going to take the rectangle and you're going to add the cylinder. So I've got 1008 plus 201.1, and that's going to be equal to 1209.1 feet cubed, and let's put a box around our final answer. Okay, you should be able to solve the next question on your own, number 42. It's a composite shape, and the two shapes are a cylinder and a cone. Go ahead and figure that volume out on your own. Alright, I'm back. Let's take a look at this. When you solve this one, you should have found out that the volume of the cylinder was 2211.7 feet cubed, and the volume of the cone was, don't forget, this is 1/3 base times height. That's going to be equal to 938.3 feet cubed. So the final volume, the total volume, you're going to add the two together. It's 3,150.0 feet cubed. There's our final answer. Now the second part of this question, just to review with you so you can do this on the test if needed. If 1 cubic foot is equal to 7.48 gallons of water, how many gallons of water will the tank hold? We got to convert cubic feet to gallons. Easy peasy, class. Start off with our cubic feet. 3,150 feet cubed. Change that to a fraction. You don't have to do that, but it makes sense to me when we do that. And we're going to go ahead and create a conversion ratio that's equal to 1. So we can multiply anything times 1. It's not going to change our answer, just the form of our value, but not the actual value itself. We want to cancel feet cubed. That means feet cubed has to be on bottom here. We want to convert to gallons. That means gallons has to be on top. And we've figured out that from our conversion here, we've got 7.48 gallons is equal to 1 cubic foot. And that fraction is equal to 1 since these two values are equal to each other. Alright, we can cancel feet cubed. We're going to multiply across. 3,150 times 7.48 is equal to 23,562. 1 times 1 is just 1, and we're going to have gallons because the gallons did not cancel. So there is our final answer. So be careful that you start just getting in the habit of taking, oh, whatever Mr. Z gives us as an answer, just divide it by this number. No, in this case, when you write the conversion fraction or conversion ratio, you see this as a multiplication of the 3,150 times 748. And the numerator just changes to 1, so we don't have to write it. All right, let's go to question number 43. We're almost done with test review. A sphere has a volume of 350 cubic inches. Remember when you see that? That's just this, class. That's just inches cubed. It's another way of saying inches cubed. If the size of the sphere is dilated by a scale factor of 2.5, remember, class, any scale factor greater than 1 is an enlargement. The question is, what will be the new volume of the sphere? So we're going to take this sphere, we're going to grow it by 2.5 times. Now, my final answer better be bigger than 350 because this is an enlargement. If it was less than 1, like 44, it's going to be a reduction. The key thing to remember here is when you grow something or you scale something that is three-dimensional, you scale it 2.5, you multiply 2.5 times all three dimensions, length, width, and height. That means in order to get your new volume, you're going to take your original volume and you're going to multiply that times the scale factor times the scale factor times the scale factor for all three dimensions. We can simplify that by writing the scale factor cubed. So let's put this in our calculator. I'll move this over. So we've got, oops, I still can't see it there. Let's try one more time. That's better. Barely. All right, so we're going to take 350 and we're going to multiply it by the scale factor, and then you're going to use your little hat or your exponent symbol, the little arrow pointing up. You're going to raise it to the power of 3 and press equal, and you see it's grown a lot. 5468.8 if we want to round it. So 5468.8, and we're still dealing with cubic inches. So I suggest that you try the next 3 of them on your own. They're all the same strategy. Take the original volume and multiply it by the scale factor cubed. Okay, hopefully you've tried 44, 45, and 46. So for 44, your final answer should be, I'll write out the work for you one more time. We've got an original volume of 2,500,000, and we're going to scale it by a factor of 0.8, but because this is volume, we're going to do that cubed since we're affecting all 3 dimensions. And that's going to end up with a number 1,280,000, and that's meters cubed. Question number 45, the answer is going to be 45.3 centimeters cubed, 45.3 centimeters cubed. And question number 46 is going to be 3,615.8 centimeters cubed. 3,615.8 centimeters cubed. Notice that question number 44 is going to be a reduction. It's going to be smaller than the original. Question number 45 is clearly a reduction because this is less than 1. And question number 46 is going to be an enlargement because the scale factor is greater than 1. Alright, question number 47. A cake has a volume of 350 inches cubed and it cost $15.95. What is the cost per cubic inch? You're going to need to know this for one of the questions on the test. Here's the key thing on this, class. When you see the word per, and I'm losing my voice a little bit, so sorry about that. When you see the word per, I want you to think about this. When we were doing scale factors and ratios, when you saw this, 3 to 1, this 2 meant that you were going to write this as a fraction, 3 over 1. Okay? The word per means the same thing. Cost per cubic inch, that means we're going to have cost on top and cubic inches on bottom. That's our tip-off with how to solve this. All right, let's do that. Our cost is $15.95. Our cubic inches is 350. Let's put that in our calculator. So 1595 divided by 350. When you press equal, you're going to get how many dollars it costs per cubic inch. We're going to write this out to 3 decimal places, 0.0, 4, and the 5 is going to change to a 6. So 0.046. Now that, I'm going to put a dollar sign here because that's what we're going to have. This is dollars per cubic inch. But dollars is kind of hard to deal with when you're looking at such tiny numbers. And so normally, instead of leaving it in dollars, we're going to take the dollar answer, 0.046, and we're going to multiply that times 100. Because that's going to get to change this number into cents. Because we know there are 100 pennies in a dollar, we can multiply this times 100 and actually get the answer in cents. So 0.046 times 100, and now you see you've got 4.6. And so our final answer here would be, it'd be 4.6 cents. And that's how much it costs per cubic inch, 4.6 cents. Go ahead and try the next one on your own, and then we'll come and give you that answer. Okay, so question number 45. A piece of pumpkin flan has a volume of 224 centimeters cubed and a cost of $5.50. What is the cost per cubic centimeters? That means cost is going to be on top and centimeters cubed is going to be on bottom. And when you do that, you're going to end up with a dollar value of 0.25, which is rounded. You're going to multiply that times 100, and you're going to get approximately 2.5 cents. So be able to solve these problems and figure out how to find the cost per volume unit. Either cost, in this case, cost per cubic centimeter, cost per cubic inch, cost per cubic foot. All you got to remember is the word per is the same as the word to. When you see a ratio of 3 to 1, it's 3 over 1. When you see the word per, it's cost over or divided by cubic centimeters. That's the end of your review sheets.